In previous sections, we were introduced to exponential and logarithmic functions and their properties. In this section, we will learn how to solve exponential and logarithmic equations. We can see the steps here. There are 4 steps to solving any exponential equation, and we will go through the steps as we do each example. Part A, 3 to the x equals to 23, and we want to solve for x. So step 1 says isolate the exponent, which it's already isolated. Step 2, if necessary, write as a single exponential expression. So the exponent has to be written using one base and as a single expression, which it's already done. Step 3, take the natural log of each side. So we're going to take the natural log of the left side. So we have natural log of 3 to the x. And if we do this, take the natural log of the left, we also have to take the natural log of the right side. So now we take the natural log of the right side, which gives us the natural log of 23. Now, why do we do this? Well, our variable x is an exponent. And when we take the natural log of both sides, by the properties of logarithms, this exponent becomes the coefficient and comes to the front, which is what we want. So now the exponent's going to come to the front. So now we have x times the natural log of 3 equals to the natural log of 23. And now we can just solve for x by dividing both sides by the natural log of 3. In a calculator, we would input the natural log of 23 divided by the natural log of 3. And this yields 2.854 as the answer. Now we can check the answer by plugging it into the original equation. The original equation being 3 to the x power equals to 23. So let's do a quick check. If we did this correctly, then 3 to the power of 2.854 should approximately be 23. It won't be exactly 23 since we rounded, but it'll be approximately 23. So let's take a look. If I take 3 and I raise it to the power of 2.854, this gives me 22.99, which is approximately equal to 23. So that's a very quick way to check your answer. Okay, let's go to part B. We have e to the 4x plus 1 equals to 21. So step 1, isolate the exponent. It's already isolated on the left side. Step 2, if necessary, write as a single exponential expression. That's if we have multiple exponents, which we don't. Step 3, we take the natural log, ln, of each side. So I take the natural log of the left side, and I have the natural log of e to the 4x plus 1. And if I take the natural log of the left side, I have to take the natural log of the right side, which gives me the natural log of 21. How does that help us? Because 4x plus 1, this comes to the front and becomes a coefficient. So this comes to the front, and we have parentheses 4x plus 1 times the natural log of e equals to natural log of 21. Now, one property we have to know is that the natural log of e is always equal to 1. So because the natural log of e is equal to 1, we can just discard it. That's equal to 1. So now I have 4x plus 1 equals to the natural log of 21. And now to solve for x, I would subtract 1 divided by 4. So I'm going to get x equals to the natural log of 21 minus 1 divided by 4. If I were to solve this equation, I would first subtract 1 from each side, divide by 4, and this is my answer in exact form. I can also use this, I can also write this using a decimal approximation. And in MyOpenMath, some of the questions will ask for exact forms, which would be the ln 21 minus 1 over 4. Some of them will ask you a decimal approximation. So the decimal approximation is 0.5111. Okay, let's take a look at our next example. We have 13 e to the x equals to 9. So step 1, it says isolate the exponent. Now in this case, the exponent is not isolated. Notice that the e to the x, the exponent has a 13 in front as a coefficient. So the first step, if you want to isolate the exponent, is we need to divide both sides by 13. So we get e to the x equals to 9 over 13. That's going to be our first step. Okay, step 2. We need to write as a single exponential expression, which we have. We only have a single exponent on the left, so that's fine. Step 3, we have to take the natural log ln of each side. So I'm going to take the natural log of the left side, and I'm going to take the natural log of the right side. Okay, so if I do that, let's take a look at what happens. We have natural log of e to the x. The exponent always comes to the front. So we have x times the natural log of e equals to the natural log of 9 over 13 on the right side. We know here by definition that natural log of e equals to 1. So I can just cross that out. The natural log of e is equal to 1, so I can cross it out. And so x equals to the natural log of 9 over 13. That would be the exact form. If we wanted a decimal approximation, we just plug that into a calculator. So we take the natural log of 9 divided by 13, and that gives us negative 0.3677. Which is our final answer. Letter D, let's save this one for class. But think about how we would do this. Remember, we start by isolating the exponent. So think about how you would isolate the exponent, and we'll go over that in class. Okay, let's take a look at letter E. We have 5 to the 9x minus 5 equals 9 to the 9x minus 3. So step 1, isolate the exponent. The exponents are isolated on each side. Step 2, write as a single exponential expression if necessary, which we don't have to do because they're both single expressions. Step 3, take the natural log of each side. So I'm going to take the natural log of the left side, which gives me ln of 5 raised to the power of 9x minus 5. And on the right side, we have the natural log of 9 raised to the power of 9x minus 3. Now, as soon as we take the natural log, we have our exponents. Let me rewrite this. So we have natural log of 5 raised to the 9x minus 5 equals to natural log of 9 raised to the 9x minus 3. As soon as we take the natural log of each side, the exponents come to the front and become coefficients. So the 9x minus 5 is going to come to the front, and we get 9x minus 5 parentheses natural log of 5. The 9x minus 3 comes to the front, and this gives you 9x minus 3 parentheses natural log of 9. All right, so at this step, there are a couple of ways you can go, but what I'm going to recommend is we take the natural log of 5 and natural log of 9, and we write them as a decimal. So the natural log of 5 is going to be 1.6094. So I have 9x minus 5, and natural log of 5 in decimal form is going to be 1.6094 equals to 9x minus 3, and the natural log of 9 in decimal form is 2.1972. Okay, so at this step, we can distribute, even though it's a decimal, we can still distribute that to the negative 5, and we distribute that to the to the 9. So we distribute and we distribute. Same thing over here. We distribute the 2.1972 to both of these terms. Okay, so we have a calculator which we will need to use at this point. So on the left side, we have 9x. So we got 9 times 1.6094, which gives you 14.4846. So we have 14.4846. 0.46x. Then we got 1.6094 times -5. And this gives you minus 8.047. Okay, on the right side, we take the 2.1972 and multiply that by the -3. So we have 2.1972, multiply that by -3, and this gives you negative 6.5916. And we take the 2.1972, multiply that by the 9x. And that gives me 19.7748x. Okay, so now this becomes an equation. Yes, it has decimals. It doesn't look very pretty, but it's still an equation involving a variable x. So we need to now move all the variables to one side and all the constants to the other side. And it doesn't matter which side we pick. So I am going to move the x's to the left. So I'm going to subtract 19.7748x from both sides. And because I'm moving the variables to the left, I have to move the numbers to the right. So in the same step, I'm going to add the 8.047 to both sides. And if you want to split this up in 2 steps, you can, but I've just chosen to do it all in 1 step. So let's see what happens on the left-hand side. On the left side, I have 14.4846x minus 19.7748. That gives me negative 5.2902x. These add to 0. These add to 0. On the right side, I move the constants to the right. So I have negative 6.5916, and I'm going to add to that 8.047. And this gives me 1.4554. As a last step, I have to divide both sides by negative 5.2902. And after all that work, we get x equals to negative 0.2751. So I know that was kind of a long and complicated problem, and we'll work out another one like this in class. But before class, think of any questions you guys have, and think of anything that doesn't make sense that I can clarify before we do our next example in class. So letter F, this one we will save for class.